Very excited to be here. I will do my best to keep us on track so that there's plenty of time for questions at the end. I'm completely comfortable with people sharing things in chat along the way, whether it's thoughts, opinions, amens, or no way. I don't mind at all. I probably won't see it, but feel free to share that amongst yourselves. I know we have some other experts in the room that will have different opinions because this is parts of this are a bit biased, and that's, I think, an important piece of this is to bring my perspective to the table, but also admit that there's other really valid perspectives, things that I have on my list that others would leave off, and I'll remind you of that as we go. So with that, we will be talking about Azure Data Engineer skills for success. In short, if you are trying to understand what a data engineer actually does, which is a common topic at the meetup I run, we'll talk about that a lot in the beginning of the session. And if you're trying to understand how do I become a better data engineer, you'll get some of my opinion as someone that's been doing data engineering and led a couple of data engineering teams. You'll get my opinion on that, just one person's opinion. And then if you're wondering, well, what's this look like in Azure? What does this Azure Synapse Analytics thing mean? It sounds a little complicated. I'm going to try and give you the kind of overview, what this looks like for a data engineer, as well as, especially at the end, we'll kind of bring it back to if you want to actually get the Azure Data Engineer certification, that's the DP203 test, the skills I'm talking about will be things that are included on that test. This is not going to prep you for the test really, but it'll at least give you some context on what technologies you need to dig deeper into. And we can always talk at the end about some of my favorite learning resources for a few of those technologies. So this slide is mostly so that you can see my information and go ask me questions later. On YouTube, I post content like this. And so if you want to see like a longer view of Synapse Spark, I have at least a couple of videos in different Spark languages for you there. If you want to know how to do monitoring and things in production, I have that sort of stuff. And I have a few random things mixed in too. So yeah, no matter what you do, if it's within the cloud, within Azure, at all related to data, you could go check it out and see what you like. You can find me on dustinvannoy.com where I have some written blog posts, as well as I share a lot of my videos there. And LinkedIn is a great place to connect and ask questions. And I do my best to respond to LinkedIn questions and invites. I try to get YouTube as well. That's a little harder for me to stay on top of. So with that, I forgot to invite you to the Data Engineering San Diego Meetup. We are still doing Zoom events, which means you can find us on meetup.com, search for Data Engineering San Diego, or just connect with me on LinkedIn. You'll see me post about it once a month. And we have another session coming up, I think March 16th. So join us for that discussion too. We talk about different topics and then have group discussions so that it's not just one person's viewpoint and opinion. We can actually try to help each other out in the community. So we have a San Diego base. Of course, I am based out of San Diego myself, but we open it up to anyone that wants to join since it's on Zoom. So here's our agenda, and we will spend the bulk of the time on item 3, but we're going to start with what the responsibilities of a data engineer is. It's a little bit of defining what a data engineer is. It's also trying to call out some of the things you may be doing a lot as a data engineer. Not every person does everything, but we'll talk about some important items there. We'll talk about the skills of a data engineer, and this is not just Azure for that portion. We're going to talk about if I want to become a data engineer, if I want to be a very marketable data engineer that can switch jobs or do consulting, these are the types of skills I should consider learning and becoming, at least able to jump in and contribute on a project with. We will talk about the Azure Data Platform architecture from a data engineer viewpoint, very much based on what is on the Azure Data Engineer Associate exam. So I kind of focused on technologies that are on the exam, though I'll probably give some honorable mention to things that I find being used a lot within Azure or whichever environment you use as a data engineer. And we'll talk a little bit at the end about a certified Azure Data Engineer, a little bit of quick tips that I've got for you there. Where are we at? There we go. All right, back on track. So the question that I get the most often is, what the heck is a data engineer? I forgot to put in my superhero slide because the data engineer is kind of a superhero that flies in to save the day. But let's get more into the nitty gritty, the responsibilities that as you sign up to be a data engineer for a team of data people that you're working with, a lot of times one of the core things they're asking you to do is collect and organize the data. So this is very broad still. We're not saying how to do this, but Data is going to live in a bunch of different systems that are either internal to the company, third-party systems that the company puts their data onto and uses, like a Salesforce or other cloud providers, or even public data that would help you do better analytics and modeling. And so it's partly bringing that into a place that it can be accessible for a lot of use cases, typically analytics focused, though data engineering can span beyond just analytics and data science, and organizing that data to where it's useful, despite some of the jokes and things people say. If you're building a data lake, if you're building a data warehouse, any sort of data system, you have a goal of organizing that data and making it something you can find. You're not just trying to pile it all up somewhere without thinking about it. So it's hard to do it well. And that's why people joke about data swamps and things like that, because it's so hard to do a well-organized system of data with a lot of different data collected in it. But that is a responsibility that we do as data engineers. Another responsibility is transforming and cleaning the data. So most data engineers both pull the data in, like ingest the data, we'll call it, and then do transformation and cleaning of the data. And really what you're trying to do here is start pushing closer and closer to it being really easy to use for other people, as well as avoiding mistakes, because mistakes in analytics and data science can be costly. If people are given a lot of bad data one day when they've trained a model on very different values for the data set, it can take a little time to figure out what's going on and correct it and avoid making any mistakes that lead you marketing to the wrong people, locking the wrong people out of your system, that sort of thing. Speaking of locking people out of your system, there is a responsibility for securing the data that comes to data engineers. In the best cases, at least in my opinion, for me, in the best cases, you have some security experts and policy people that are available and talking to you about what standards you need to follow, which data is highly sensitive and needs extra encryption layers on top of it. But you still are responsible for making sure that you're asking those questions, that you're applying the security that you're in charge of as you load the data, and that you as an individual within the company are being responsible about the data you use for development and any data that ends up on your laptop and those sorts of things. So securing the data is something that you cannot ignore as a data engineer, though you don't have to be a security expert if you have others around you to support you. Making data valuable is another thing that I think you can't lose sight of as a data engineer. And so sometimes data engineers go through their role and don't worry about this piece. And if you have a big team around you, if you have people that are worried about the data value, you may get away with that. But I find the best data engineers are going to consider, how is this going to be used in the end? How do I make sure that this isn't just available data that's been cleaned based on, the obvious things, but it's actually something that's going to be so easy to use that people come back to me and, give me a free coffee or something because it's had such an impact on their job. It saved them hours and hours of time, which it's funny how much people like you if you do something that saves them hours or days of time every time they have to pull together some big report for the CEO or external parties. And now some data engineers find themselves mostly in this one responsibility. Some data engineers don't do this at all, right? So these aren't exactly every data engineer does every one, but supporting data science and analytics is something that typically is either the focus of the job or it's a small piece, but important piece of the job of a data engineer. So if you think about, you've transformed the data, tried to make it valuable, secured it, tried to organize it, when it comes time for those end users, which a lot of times your end users are the analyst and the data scientist, when they're ready to use it, you want them to be successful, right? You want to be the kind of consultant, whether it's internal or external. You want to be the consultant that helps that team get what they need quickly and have success with it. Otherwise, they won't use what you built and they'll find other ways to build it, right? If you've been around analysts and data scientists, they are very skilled people as well. Whether or not data engineers or data scientists are more technically skilled, that's a debate that doesn't lead anywhere. But you'll find data scientists will find a way to get things done with whatever data they get. And so if they can't get to your data, they don't understand where to find the data, you're at risk of doing a lot of work that never gets used. So don't forget supporting data scientists, analysts. Sometimes this is more like business users if you have a self-service ecosystem. Don't forget this responsibility. Okay, so these may not apply to every data engineer. I'll say that for the last time, I think. But here are my responsibilities that I think are typical for a data engineer. Similar note are the tasks that a data engineer does. So this is if I were to start to try and share about what am I going to do day to day as a data engineer. We have these responsibilities. They translate into these tasks. So for collect and organize the data, you're going to be doing data ingestion. Sometimes this just gets labeled as ETL, extract, transform, load. Ingest is kind of the first piece of typical ETL process where you pull it from one system and put it into your environment. Transform and clean the data. This lines up really well with the responsibility. There's actual work within the extract, transform, load jobs, or the data pipelines is another term we use for these types of jobs, where you're going to clean it up, transform the data. The more you can do this in a reusable, automated fashion, or at least reusable fashion, we'll focus on that for today, where you've built libraries that automatically clean up addresses, maybe use some additional services and APIs to clean up addresses, the better off you'll be as a data engineer. Productionized data science is another key thing for a data engineer. I was gonna see if I can read that. Is that you? Over here. All right, back on track. Productionizing data science. Let me know if you can't hear me and I will fix it, but I think that was someone else's mic coming through. So productionizing data science, this comes along with supporting data scientists and analysts, but I want to call out that in some places, I think we're getting better about not always having to do this, but in some places, some organizations, the data science team will build these models, do a lot of work in R or Python, but when it's time to roll it to production and actually process data either in real time or on a regular cadence, the code needs completely rewritten to process the data in the way that is expected by the models. And so that type of work is very interesting work, and it still sometimes falls to a data engineer. But even in cases where you're giving the data scientist more and more control over the final production code, usually the data engineer is there to kind of help them stand up the systems. Sometimes they're helping with deployment pipelines and things like that. So the more you know about data science, machine learning, those types of capabilities, the more likely you are to fall into this type of role. The less you know, the more likely you are to not be asked to help at all, and you'll focus on just preparing data that gets used. Okay, building data platform tools. So this is sometimes a completely different role. Some people don't even call it a data engineer, but I group it in that category. Sometimes it's a data platform engineer is kind of a good word for it, or a software developer on a data platform team. But some data engineers really don't worry about the actual like data itself and cleaning it and making it valuable. They worry about the systems and tools that are going to be reusable across a whole lot of teams. Sometimes it's analytics teams. Sometimes it is like your product teams that are building out the platform that you sell to customers. And so this is a certain type of role sometimes, but even if you're focused on analysts, like a lot of my roles have been, if you're focused on the analyst team, you still want to think about what kind of capabilities can we build in that are going to make it easy for analysts and others to work with this. So not just providing data and saying good luck and letting them hook up their favorite, visualization tool to it, but also making sure that you build it in a way that they can contribute better to how to get the views and the capabilities they need. That's kind of a longer discussion getting into how to pull that off, but just know that, in my opinion, is a very valid role for a data engineer. And it's an important task to consider of how can I take what I've already built and make it more accessible for others within the data team that aren't data engineers to utilize and basically save me time instead of having to rebuild the same thing over and over again because they don't have the capability to do it themselves with the tools I built. So these are my tasks for a data engineer. I'm sure I'm missing a bunch that people do every day. We kept the stand-up meetings and the all-hands meetings off the list because while those sometimes come with the territory, those are not important for a data engineer. That's more a company organization thing, right? But let's quickly look at the traits that I recommend kind of working on, practicing, thinking about if you're trying to be a very successful data engineer. So before we get into skills, we're about to get there. I highly recommend considering whether you're approaching your role, approaching your day-to-day with very problem solver type of mindset, trying to do a good job of problem solving rather than just following directions. Because usually their directions are wrong. They don't know exactly what you do, how you do it, how you can do it successfully, and you need to take the problem at hand that they're giving you and find the best way to solve it. This kind of applies to a lot of tech roles, but I just I can't help but think about it when I think of the data engineering projects I've been on, and sometimes a lack of clarity that I get when I'm asked to do something. Taking initiative in the same light, taking initiative is super important because you need to reach out and ask questions. You need to reach out to get access to systems. You need to keep an eye on what you build, take ownership of what you build, and make sure it works. You can't just throw it over the fence and expect someone else to make sure your project's successful. I don't think. The bigger the team, the less likely each data engineer needs to do this. But the data engineers I want on my teams usually are taking initiative on the things that we ask them to work on. Actively learning is super important. People might even today in the question time bring up technologies like, instead of Synapse pipeline, shouldn't I just use DBT or Fivetran? And I'll say, I don't know. I know some people that know, but it's hard to keep up on the pros and cons, the strengths and weaknesses of every new technology. But if all of a sudden tomorrow I find out that DBT is the tool for what I need to do for this project, I'm going to be learning it on the job. And I've had a lot of practice at that, because as you get further and further into data engineering, you'll see that the technology changes, the goals are the same, the problems are the same. We just have to learn the new technologies and their pros and cons really quickly in order to keep delivering that value, right? We can't lose sight of making the data valuable and making our project successful. And then being a team player, no matter what you do in life, my recommendation is be a team player, help others, not just because that's the right way to live, but also because you will find you get better job opportunities when people reach out to you to join their team because you're so helpful to work with. So keep that in mind as you go. Skills, we're on the skills. So if you didn't like that stuff, time to wake up. We're going to start talking about some general skills for a few more minutes, and then we're getting straight into Azure architecture, okay? All right. So the top thing I put is a programming language, and Python or Scala are the ones that I see the most for data engineering. As he mentioned, I'm an Apache Spark developer with a lot of my time. And so Python and Scala are the go-to languages for Apache Spark. That's probably part of the reason I have this bias. But even when people are not using Spark, I see a lot of Python and Scala. So I recommend getting comfortable with one or both of those languages. But if you know Java, if you know .NET, I think Rust is starting to get more into data engineering. Go might be doing some more data engineering. I've seen some good roles there. There's a lot of programming languages, but being able to develop code that can do what needs to happen is a really good strength to have and often required for a data engineer these days. Now, somewhat the alternative, but I think it's really something you need to do hand in hand. I highly recommend having SQL as well as the coding background, the coding skills. If you know SQL now and don't know Python or Scala and you want to do data engineering long-term, I'd say learn them. If you know Python or Scala and don't know SQL, learn it. That's what I'm trying to tell you with these first two items in my skills list. So SQL is what we use for relational databases, which many of us know. It's also something that can speak to a lot of big data systems that are not relational databases at all, because it's kind of this common language in data. It's the language that Power BI and Tableau and other visualization tools tend to want to use. And so if you know SQL, you can write code for a lot of systems even before you learn Python, Scala, other types of languages. The other thing about it is that you have a good chance at some point in your career of inheriting something written with a lot of lines of SQL code, and you'll be asked to build it in a better, different way, migrate it to the cloud, those types of things. So SQL is something worth learning. With this group, I don't know, I might be preaching to the choir, but I just wanted you to know SQL, Python, Scala, you learn those two things, you're well on your way. Now we're starting to get to the ones where if we were a group of people around a table, we could argue about a little more. I'm putting Spark and Hadoop high on the list. If you kind of understand what these are, I'd say if you substitute any distributed system in here, we're on the same page. The idea of having code that runs in parallel with distributed storage makes use of scaling out by adding more nodes to a cluster. Those types of technologies, whether they're hosted in the cloud or something you stand up yourself, are really popular in data engineering at this point. I think they'll continue to be really popular in the future. So I'll share a little bit more about Apache Spark when I'm showing you some of the Azure technologies, but I think it's a really one to at least get familiar with, know how to do some basics with it so that you understand where it might fit in a data architecture. Now we're going super vague, and I'm sorry about that, but cloud analytics services. So what do I mean by that? If you're in Azure, if you expect to be in Azure, the things we'll talk about like Databricks, Synapse Analytics, Stream Analytics. What else? Even just Azure SQL databases. The services that the cloud provider offers to try and keep you from standing up VMs or actual physical hardware and installing things yourself. These services usually give you some way to get started quickly, maybe save some money, maybe do some things that are just a lot harder to do with open source technologies within that specific cloud provider. And so when you go to a company that's using the cloud, a lot of times they want to at least consider the built-in services for that cloud provider before they go stand up something like an Airflow or Apache Kafka and manage it themselves. NoSQL, any day now I'm taking this out of my list, to be honest with you. Not because it's not still relevant in the data space, but for a data engineer, it's good to understand the concepts of NoSQL. It's good to consider where it would speed up the reads and writes that are going to happen. But if you're trying to load up a data lake or data warehouse, which is often the focus, you probably won't even use NoSQL at all. If you're doing something like a feature store, there's going to be a lot of lookups of specific items, then NoSQL starts to play a part. So read up a little bit, just understand kind of where it might fit, and you'll probably see that it's typically not the main thing a data engineer works with, unless you're very much part of like a software development team, a product development team, rather than an analytics team. And then software best practices. You may know this by now. I think it's gained a lot in its popularity as something data engineers should know, but I did a lot of data engineering where I'd come from the more analyst BI background and then started writing a lot of code and deploying it into these systems that were in the cloud. And I didn't know at first all of the testing practices that software developers recommend and often force you to do if you're if you're writing code and building up like packages of software as part of their team. As I started to listen to what they had to say to me about what I was doing, learn more of that, it gave me an easier time working with and partnering with software development teams, which often is an opportunity for data engineers to do. It also taught me some things that made my code and my data engineering projects work better. And so just don't skip over all of these practices, even though they apply a little differently to us. Yeah, we'll leave it at that for today. So these are my top skills for data engineer. The top two I highly, highly recommend, or substitute a different programming language and just, kind of focus on jobs that require that language. The other useful skills though, and you may have been wishing I would say this, waiting for me to say this because this is your thing. So I'll throw them up here and just real quickly mention that like ETL and orchestration tools that are more like UI driven ETL or orchestration tools are important. They do play a role. I'll show you a role that they play within Azure Synapse in a bit, but Azure Data Factory is kind of the Azure version of that. Streaming, like using Event Hubs or Apache Kafka as the middle layer to stream data around, I think is really important. I would highly recommend people learn this, but the truth is there's a lot of jobs where you're not going to be asked to do streaming yet, and so you could probably get by without it until the need arises. So if you're actively learning, maybe you don't dive into this quite yet, but I think it's a really good technology to learn. Data visualization, you may or may not use. It's always helpful to be able to connect to your data, profile it, maybe build a couple sample reports to show the power of what you've built, but it may not be necessary. I don't often have a visualization tool installed on my laptop, and then I just install it when the need arises. Machine learning, AI, it depends on your role. This can be really helpful. It's always a good data engineer can transition to this fairly easily if you learn the required skills, but supporting machine learning and AI models, data pipelines, those kind of things is a common thing. So it's a good one to know. If you love digging into it, dig deeper and look at roles that require that. And DevOps is one that isn't my favorite thing to do or learn, but I find as a data engineer, often the DevOps specialists, there's not enough of them. We can't find them. And so what I mean by DevOps really in this case is automated code deployment to go from development to, or really my laptop to development to UAT to production. That piece, the more you understand how you can pull that off, the more helpful you can be when it's time to deploy code and things aren't exactly right with your deploy pipeline. So it's a really good thing to know. Not going to spend your time on it today. Those are just things that I recommend looking into if you feel like you check enough of the boxes that you want to check on my first list. Here we go. Data platform architecture. This is I'm saving you from any complex architecture diagrams. I kind of like simple diagrams. Sometimes I draw them on a piece of paper, but I went ahead and built this one in PowerPoint for you all. And when we're looking at ingesting data to a data lake, let's say, this is my basic set of paths that I would probably have in Azure without worrying about a lot of the little details like key vault and networking and things that come into play in the real environment. So we're going to read data from sources. Often there's some databases or cloud systems with APIs that we're going to pull from. Sometimes, and when we're doing that, we're usually using Azure Data Factory or Synapse pipelines. They're more or less the same product for what I'm going to be talking about. We're using those to orchestrate a flow of dependent code that's going to be our data pipeline. So Azure Data Factory is our orchestration tool. And we often are going to be calling some type of Spark notebook. In this case, let's say we're using Databricks. We would run Databricks notebooks. I'll show you what that looks like in a few minutes here. And those would process the data, land it to the data lake. Maybe we have additional steps that read it back out with Databricks, do some processing, land it to the data lake, or take it to another storage layer that's going to be easier for the usage that we have, such as like a dedicated pool in Synapse Analytics, a SQL Server database, something completely different. Snowflake, if you go that path. The other thing, though, is that our applications are like phone apps, our mobile apps. Usually it's a web service itself that would do this, but the web service driving our applications might be streaming data into Event Hubs. So that means each time something happens, it sends a message to Azure Event Hubs. Azure Event Hubs just collects that for us, and then Databricks is either going to, as quick as it can, pull data off, or every hour, every 15 minutes, pull a batch of data off, process it, and do the same sort of flow I talked about, but reading from Event Hubs rather than waiting for a scheduled job from Data Factory. Hopefully, as we look at the technologies, this kind of fills in the picture a little more. This is what that same thing looks like within Synapse. So we took away Data Factory, put in Synapse pipelines. We kept Event Hubs for our streaming layer, right? So streaming is on the bottom, batch is on the top. And I like to go with Synapse Spark. So I basically am showing a picture of we'd run Synapse pipelines that call Spark, load the data lake, maybe pull data back out, do some more stuff, probably store it in the data lake before a final layer might push it to a different system for our final analytics and data model analytics and like scoring and things like that our data science models would do. Stream analytics is an alternative to doing streaming within Databricks. You could do streaming within Synapse Spark as well. It's a little bit trickier to get set up than with Databricks, but from what I've seen, it works, and I think as long as you monitor it and keep an eye on it, you'll be fine. But Stream Analytics is kind of a built-in tool for streaming, and we should have time to look at that here as well. All right, so that was the somewhat big picture, a part of the architecture without worrying about our final like data warehousing storage layer. Let's talk about what Data Factory is and why it sits there. So Data Factory and Azure Synapse pipelines are, for most use cases, going to give you the same kind of functionality that you might use. So just consider this either one of those technologies for what I'm about to say. I like to use these as an orchestration tool to organize code that I've written. And sometimes I'll use the copy task to copy data in from one system into my data lake before I have Spark or maybe some serverless SQL scripts do additional processing. But what's really cool about it is you can run serverless data pipelines. You can build this mapping with the UI, a lot like SSIS is if you've worked with that in the past, and load data that way. So you can totally go that path. Some people love it and talk about it a lot. I'll let them share the pros of that side. I like to use it to call Spark code and other types of code. It has some scheduling and alerting that is helpful built in. I also am going to recommend now that if you're going to try and take this certification exam, the DP203 exam, check out the scheduling and alerting. Don't forget to look at, if I actually run a real set of code, what's this thing look like? What are my options? Because that does come up to actually know how to use this stuff in like a real production scenario, not just how do I write a little code and hit the debug button, which is usually how you start. And it has autoscale capabilities, which is always something I'm looking for in platforms. I'll show you a bit of how I use Data Factory, really Synapse pipelines soon. Let's talk about Databricks, though. I really like Azure Databricks. I've worked with it a lot. They describe themselves as a unified analytics platform. I tend to talk about them from a data engineering view as like managed Apache Spark. So it's Apache Spark with a lot of extra, a lot of extra capabilities, a lot of optimizations, and things that just make the experience of working with Apache Spark way better than when I went and stood up Apache Spark on virtual machines. May have even been a Hortonworks distribution back in the day, but running Apache Spark ourselves was not nearly as easy, as pleasant. We weren't as effective at getting code delivered as with Apache Spark. So that's kind of where I look at it from. If you're into machine learning, there's a whole set of features you should look at. If you want to make Databricks your lake house to deliver data all the way to Power BI and maybe to live queries, you can look at the SQL workspace they have and some of the engine that they built to optimize performance for reads. There's a lot built into Databricks that I won't really get into, but looking at it as a way to write Spark that will do data pipelines is a very good way to look at it. And I think I'll be able to share a little about their kind of improvements in job scheduling and things too, which might eliminate the need for Data Factory for you. And then auto-scale and auto-terminate capabilities. I think most things you would consider in the cloud have caught up to this by now. But for a while there, they had better auto-scaling, auto-termination than a lot of the tools I would use. So we're going to jump into a demo. I want to give you just kind of a quick, here's what it actually looks like for those that haven't seen it. And then we'll come back, talk more about Synapse Analytics, and then we'll take a demo of that. So here we go. You gonna let me? There we go. Okay. So once you've logged into your Databricks workspace, you would see a screen much like what I have pulled up. You can quickly create notebooks. There is a data import tool. I don't know if I've actually used that one. You can see your recents, but the thing that I want to call out for you, just to give you an idea of the features that it offers when I say unified analytics platform, what does that actually mean? So it has a way to manage your code through repositories. This is like source control, version control for your code. And I think this is a more recent feature that I think is really powerful if you're going to write a lot of code within Databricks notebooks, which some people really love to do. Using repositories to store changes to that code, be able to do things like merges is a really powerful thing that it offers. Synapse has something similar, though I think they're quite different in how they actually play out for a developer. It has a data section, so I hope my cluster's still running. All right, cluster's running. We might actually get a little bit of a live demo on this one. It has a data section where you can actually build tables and browse them, and it looks a lot like if you're querying any sort of database. It acts different when you query it. The timing is going to depend a lot on the file format in Azure Storage, but it looks the same, and so it's easy to get the hang of if you're just trying to come in and query data that someone's already built for you. Compute is where a lot of magic happens. It's far too broad for me to spend a lot of time on, but you can create clusters super easily through the UI. You can also automate creation of clusters through an API or through a command line interface for those automated pipelines that you'll end up wanting to do for production. But you can easily get things started, create a cluster, play with the settings, figure out what you want. I have one of the latest ones up, and it's a pretty recent version of Spark. I'm trying to think if they made GA another version of Spark yet, but it's a pretty recent version of Spark. It's pretty up to date. Some of the tools that you might use with it might lag a little bit, but they give you a pretty good runtime quickly once Spark releases another minor version. You have auto terminate, like I said. What I mean by this is if I stop doing anything, it's going to turn off after 120 minutes, and you can cut that down to shorter for testing. You can set up auto scaling where you can go from 2 to 8 workers or whatever you need, which is really powerful if you're going to run batch jobs on a cluster that's on a lot or reused. And then there's a lot of advanced options. I guess the thing I'll call out is don't forget to think, if you're really going far with this and building production jobs, don't forget to think about your configurations, Spark configurations, which you can easily add down here. Environment variables can pull from Key Vault and give you a secure way to pass information into your clusters. And you can set up init scripts to do some things. You'll probably find yourself needing to do this before you think about wanting to do it, is the way I find it. If you want to do logging, you can send stuff to Azure Storage, and I've got a video on YouTube about how to set up logging all the way to log analytics, which is my preferred way to do logging with Synapse Spark or Databricks Spark. When you run jobs, there's a UI that's, I'd say it's a little better than the regular Spark UI. It's got some capabilities that are cool. You can see some logs in the view. Who cares? It's good, but really what you want to do is get those to log analytics or look at the UI typically. And then the other thing that's really important to know before we look at a quick notebook is that we have an actually pretty decent job scheduler built in now. Again, you can create jobs through an API or through the UI. I can add multiple tasks to a job. I can set up dependencies. I can either run notebooks, which is kind of their default, or I can run some code that I've saved and made available to Databricks environment to run. And I can run job clusters. So I can spin up a cluster just for this job to run, or I can use an existing cluster. You get better cost if you spin up job clusters, especially I think definitely look at the cost if you're going to schedule jobs, because if you spin up a cluster just for that job, and I think if you're running Python or jar rather than a notebook, I think you save a decent amount of money per hour if you get to the point that that matters to you. But you can chain together some different pieces of that job. You can set a schedule. I think I've got a nothing scheduled because I don't want to keep paying them to run demo code all the time. But when you run it, it'll tell you if it failed or succeeded, and you can easily kick it off manually just by hitting play. So jobs is a pretty powerful thing within Databricks. Sometimes I've seen it used a lot, and other times I've seen it completely ignored, and we will run things through either calling the API directly or setting up Data Factory or Synapse pipelines to run the job. Okay. So I am not going to explain Spark syntax to you today, which probably some of you are glad I won't spend time on. But this is we're going to start with a SQL-only notebook. So you can easily create a notebook in Databricks. You'll see a similar thing in Synapse. If I wanted to run only SQL, you can tell it tells me which language I'm using, SQL versus Python versus Scala. I can write SQL statements that are probably pretty familiar to you. The syntax may be a little different. It's a lot closer to the Hive syntax if you're familiar with that. I can drop and create tables if the data already exists in a place that's available to me. In this case, I've mounted Azure Storage, and I can just create a table right on top of that without knowing Python or Scala or really knowing Spark, just learning a bit of Spark SQL. I can query that data. This is CSV data. So a key thing to know if you're kind of new to data engineering is that, what was this? This was a count. The count on CSV wasn't too bad. It only took like 13 seconds to do a count, but a count should be really quick, right? If we have an index table in a relational database. When I try and pull the top 10 records for a period of time off of CSV, almost 2 minutes there. So if I'm doing ad hoc analytics just to explore the data, I can handle that. But really, you're going to want to think when you're doing Spark of any sort, how do I store this data in a way that's going to be more efficient for querying the data directly on my Azure storage system rather than from a database that's doing its own indexing within it? And so the quick tip down here for those that are following along is that you can create tables with either a Delta format or a Parquet format. Both of them are pretty optimized for reads. Delta is easier to kind of manage changes to the data in, especially within Databricks. They have some extra capabilities for Delta that aren't available in every other platform. So if you create a Delta table, we basically just reload all that same data I had in CSV to a Delta table. And I think I have it partitioned. Yes, I have it partitioned, which is going to make speed up quite a few queries I would do. When I ran that one, it was about less than it was less than a second to get the top 10, which you would think it'd be pretty quick, but it's just set up to where top 10 is really fast. It wasn't too bad on the other one, I don't think, though. If I go and run an actual like analytics type query, it's kind of a contrived example, but if I run this query, 1.4 seconds. I might have even had some caching. I might have cheated on that one since I made sure my cluster was working earlier. But fairly quickly with Delta, it can do some aggregations because it's got some additional, the way it's storing the data in Parquet, it only has to read the columns it cares about, and it has some different like metadata about each file in order to try and quickly get the results that you're asking for. So key takeaway here, if you have no idea what I'm showing you in Spark, is when you work with Spark or any data lake tools where you're reading file data, how you store those files, the format of the file, Parquet versus CSV versus Delta, and partitioning the folders is really important. And this is a quick glimpse of what partitioning folders looks like. So my table name is basically this yellow trips Delta. That's the table name. It's really just a directory within Azure Data Lake Storage. And then Azure Storage in this case, actually. And then my year month partitioning, I have each month in its own partition. So I could quickly say query only 2002 February data, and I can skip all these other directories and not have to read through a lot of data I don't need. So similar ideas to table partitioning in relational databases. It's kind of as close as you'll get to indexes, almost as close as you'll get to indexes within a data lake. That's the idea there. Just mostly to set up our next demo, I want to show you that my actual PySpark code, so Python code that uses Spark API, we put it all together, it's PySpark. When I run this, I am able to import libraries, set variables that I use later. This right here, you can find this in my YouTube videos if you really want to dig in, is how you would create a schema in Spark, one way to create a schema in Spark. But then I'm going to basically use spark.read, give it some formats and read in some data, and then save it back out to a table that's more optimized for what I need to do next. This is just a lookup table for taxi zone data. And that type of run where it's a small file is 41 seconds it was for me. So it's really not too bad for a small set of data. Here I run a much bigger set of data. I'm reading data from CSV for a whole year of yellow trip data. I forget how much data. We might have a chart showing us. I do some transformations. I give you 2 different ways to do transformations. And I do a join. So we can do joins between this data. It's a lot easier to do it if you're doing batch jobs. When you're doing streaming, joins get a bit complex. Topic for another day. And then I can write that data back out with partitions again with Delta format, so it's going to perform well. And so that took 4 minutes to load probably gigs of data from CSV. I forget exactly, but it was a decent amount of data from CSV. You can also do streaming, and I'm going to skip this right now. I think I've got some videos about streaming. If not, talk to me. We'll talk about streaming another time because I love that topic and I can't squeeze it into this demo. So that's Databricks. We're running things in Apache Spark. A lot of times we'll use notebooks or we'll upload code and run it via jobs. And it has a lot of other capabilities for machine learning and things, a whole separate workspace for machine learning that starts to throw in like ML flow stuff, model management, those types of things that I never touch, quite frankly. Back to slides for a little bit, and then we'll start to bring this home. So Azure Synapse Analytics. I'm going to try to explain this in one slide, and then I have a backup slide to explain it again. So Azure Synapse Analytics, it's an integrated analytics service. Integrated versus unified, I don't know, but that's the way I talk about it. It's like 4 or 5 or 8 tools pulled into one place, which is not to demean it. That's a great thing. Not having to stand up a bunch of different services is very nice, but you do have to realize that you're switching services as you do your work. You have to think about the different capabilities you're going to use as you stand up your environments. But it brings it all together where it integrates nicely, shares link services, those types of things. So we can do manage Apache Spark here, and I'll show you how that code looks basically the same. And on top of doing some Apache Spark work, the serverless SQL is a capability I think is super exciting, but they also have dedicated SQL, which is going to work. If you know SQL Data Warehouse, it's kind of the new evolution of that. If you've worked with or know about Redshift, if you know about, I don't know about Snowflake, it's probably a competitor of Snowflake, but it fundamentally the concepts are more like Redshift, where you've got data that's replicated and partitioned, and it's going to be very fast for reads, whereas serverless is going to be very cheap, or at least if you're careful, it'll be very cheap. Azure Data Explorer is new. It's in preview. I have no more information for you on that. For querying log files, looks really good to me. Not sure all the use cases yet. And then autoscale and serverless capabilities are there across the board. I will say Databricks, if you're doing streaming, turn on auto terminate, but you got to kill your streaming jobs or it'll just keep running and it'll charge you for it. Synapse, if you're doing streaming especially, but even with other use cases, be careful about making sure your Spark pools turn off, making sure they're off before you leave for the weekend to avoid them thinking that your session's still going when you thought you were done. So auto terminate's awesome. Don't forget to check on it and make sure it's not running up a bill on you. Have had it happen a few times. So now, Serverless Apache Spark, I recommend for data processing and exploration. I like to write code for my data processing and data pipelines. I tend to import functions from other notebooks or from a library I build and reuse functions that just pass a few parameters and I get the same effect without having to rewrite and copy and paste that code everywhere. That's why Apache Spark's so great. Plus, it's going to give me more control of how this thing runs in parallel. I can change what size pools I use, those kinds of things to really control that data flow better. Serverless SQL for easy querying. So for exploration, for analytics that are going to basically just export the results anyway, like exporting straight to Power BI. If I can get away with serverless SQL for that, then I like to use that. Otherwise, if serverless SQL is not fitting in for me, it's not doing what I need, we have dedicated SQL for high performance, and we're talking massive parallel processing database, MPP. So what that means is it's a specialized tool for reading data. It's going to use replication, distribution, I guess is a better way to say it, distribution and sometimes replication to run a bunch of stuff in parallel, pull it back as fast as it can. And how you model is a little different, or at least how you create your tables is a little different. And you need to look into that and study that if you're going to do the exam. You probably want to look in and study that if you're going to create any tables in dedicated SQL for a real use case. The Microsoft Learn path around EP203 includes some stuff on dedicated SQL. I think that one might have labs with it. It definitely has some really good concepts in it. So check out that if you're going to work with dedicated SQL. And Synapse pipelines are great for no code or low code data ingestion. Basically the same thing I talked about Data Factory. If you're using Synapse and you want to do that type of thing, Synapse pipelines is the spot to go. If you're doing SSIS, there's some differences there in how it can be managed within Azure. And so look into that for running SSIS within Azure. All right, Synapse demo. We're going to do this. So this is going to be probably as much as I can bring it all together for you. What does a real job in Azure Synapse look like for me? I think I'm still zoomed in enough that hopefully you can see okay. So this is me within my Synapse Studio. I am on the Develop Hub. There's a few different hubs here. Let's take a quick look for those that are new. You can browse the data you've got. You can do pipelines and integration here. You can monitor and you can manage the different link services and pools and things that you have set up. We're in the Develop Hub. This is where you're going to spend more of your time as a data engineer, most likely. And I can create SQL scripts. And this can be serverless SQL or dedicated SQL scripts. I can do KQL for my Azure Data Explorer, notebooks for Spark, or you can also run Python code, but really you're trying to use these when you're wanting to run Spark. And then a few more things that you could use, including Apache Spark job definition. If you're just going to upload some code that can run on Spark and set up a job from that instead of using notebooks, that's definitely an option here. Oh, and Gallery is a great place to go and try and find examples, things that you can use that are already built for kind of demos and for learning. Okay, so what we've got here, the place this would all start if I'm scheduling a job is at a Synapse pipeline. I haven't found many other ways to actually schedule jobs with triggers beyond a Synapse pipeline. So if I want to run a bunch of Spark notebooks, I will create one or more pipelines and use this Synapse notebook task. And within it, I'm basically saying, come on, there we go. I'm basically saying, go run this notebook. And I can tell it the pool here or let it take the pool the notebook's already attached to. Go run this Spark code. That's what that does. Excuse me. When it's done running the Spark code, it's going to move to this. I don't really do this often, by the way, but this is a way to do it, so I wanted to show it. I can go run code that would work on serverless SQL. I've got the same code in one of these scripts up here. I can go create a SQL Server link service, a source data set that's a SQL Server, give it my information for Synapse On Demand, which is my serverless SQL, and run code against that and have it actually pull that data out and write it to another location, such as Parquet on Azure Storage, or really any of the syncs that pipelines can hit. More likely, what I really like to do when I can is I use Spark notebooks to create tables in databases that will be part of my Lake database. Do I have a Lake database? I think I do. Hey, there we go. I have way too much because I was testing security and I just kept copying everything. Well, look at this one. So I can use Spark to create tables in my Lake database, basically just by doing save table as or save table. And once I do that, I can query that from serverless SQL as well if it's the right format. If it's Parquet format's usually what I would use if I'm trying to do that. So that might save you a copy task to do it, but that's kind of beyond the point of today. Just kind of a tip that I would use Spark for a lot of these things and then maybe load it to another system at the end if I need to. So the data lake load notebook that I called, the Spark notebook that I call from my pipeline, it's almost the same exact code. I think the paths change a little bit. They may not have even changed. I think I changed the paths a little bit, it's pretty much the same code I ran as the first part of my other job. And so that runs. The thing about working in any of these managed Sparks is that the pool or the cluster takes a little time to load up. It's a little more noticeable when you switch notebooks here. The amount of time to create a new session on a pool is usually like 3 minutes or so. Sometimes it kind of goes indefinitely and doesn't work out. So that's something to keep an eye on with Synapse Spark pools, that you are going to take a little time when you open up a new notebook. All right, now what serverless SQL code looks like, and we'll keep this short because there's lots of good information out there about this. Serverless SQL looks more like this. You can do open row set, which you may have used in the past with Polybase. You can do open row set against some storage, give it some kind of format like Delta, Parquet, CSV typically. If you want to create external tables, you definitely can. This is a very useful capability. You just create a format. Parquet is pretty straightforward. If you do CSV, you have a bunch of options to think about, like what's my delimiter, what's my quote identifier, that kind of thing. You can set up a data source. You can even have some special credentials in here if you don't want to use managed identity. You can drop tables if they don't or if they do exist, and you can create tables. And here I haven't gone too crazy with my data types. I'm just using a bunch of varchar 4000s to get stuff available to query. And then you can select the data from it. You can also do this with So I did that. I used Parquet format on top of Delta. That's not something I typically like to do. I would probably do it with Parquet here if I'm going to set up a Parquet format and read the data. So once you've done that, you can do SQL that probably looks like any other SQL that you would run on a SQL Server Microsoft product. There's going to be a few differences, right? But you can run SQL statements that look very normal, that probably won't require changes unless you're using certain functions that just aren't supported. And let's see, I forget which one's the fastest, but we can kick one off. It'll run for a little bit of time here. I don't think that's a very fast one based on my condition there. And that's going to give us back some results. Now, the other thing you can do, I did not turn my dedicated pool on, so that's all right. The other thing you do is you can create tables on a dedicated pool, which is going to be much faster and much more expensive to run the compute for. And you're going to think about things like, do I want a cluster column store index or some other type of index? What type of distribution do I want? There's going to be 60 distributions per table in dedicated SQL pool. Do I want to replicate 60 times because it's such a small table that I'll use a lot? Or is it big enough that I want to do a hash distribution? And those are the concepts that Microsoft LearnPath will teach you. And then I don't even think it's showing up on here. Maybe you can see it. There's a copy into at the bottom, which is a way to load data from a file system into your dedicated SQL pool pretty quickly. There's a couple of options around that. Copy, I think these days is a good way to go. And then finally, querying dedicated SQL. The main thing I wanted to show, but I forgot to turn it on, is that if I run a very similar query that I can do in serverless, I think it was taking me maybe a minute, maybe 30 seconds in serverless SQL. It took like 7 seconds in dedicated SQL pool on the very smallest dedicated SQL pool you can have, because I didn't want to pay any money for it. And so on a very small SQL pool, it still runs faster than serverless. But this isn't a huge data set. So the results vary depending on how big your data is and, of course, how you store that data in dedicated SQL. So this is Synapse, pipelines, serverless SQL, dedicated SQL pools, monitoring, managing these capabilities. And you can also integrate and connect some other things that are, I guess, a little bit separate from Synapse, but you can integrate them pretty well with Synapse. All right, let's get back to these slides and bring this home. So when we talk about streaming, remember I had that streaming flow earlier in my architecture. The place that Azure Event Hubs fits in is as the scalable message broker. It's the middle layer between data coming in and data being consumed by my analytics systems. And it lets us decouple the producer, like my web application or my web service, from a consumer like my Spark job that's running a streaming read off of Event Hubs. And it gives us Kafka compatibility with, quite a bit of the Kafka capabilities. You can use the Kafka APIs. I think it's protocol 1.0, if I remember right. I might be wrong on that. And then it's a auto-scale namespace. So you can say within this namespace, which might be 1, it might be 10 different event hubs. Within that namespace, I want to scale between 2 throughput units and 10. And there's a little calculation for it to try and figure out the right size, but auto-scale gives you a little leeway. If you increase your load, it'll still function for you and scale up for you. What that means when we decouple the producer from the consumer is that I might have trip data coming in. Normally, this would be a database table. In Event Hubs, it's going to be its own event hub, a single event hub. In Kafka, that would be a topic if you're familiar with that. But in Event Hubs, it's an event hub. Vendor data normally would go to a table. Instead, it's going to an event hub. And I have multiple consumers that know nothing about each other and may not even know much about the producer besides the schema of the data that it's producing. And so we have the data lake and our real-time reports and some other type of user dashboard that's built into the product. And the producer doesn't have to know a lot about those consumers. Consumer doesn't have to know a lot about the producer. You just have to have some sort of schema contract that is used on Event Hub. Now, if you're going to be consuming from Event Hubs, you can totally do that with Azure Databricks, and I've done quite a bit of that. You can also do it with Azure Stream Analytics. And so Stream Analytics is fully managed streaming within Azure, and it's meant to basically let you write SQL code to do streaming. So it's the Stream Analytics query language. It's standard SQL, and then there's some inputs and outputs that you configure that are built to let you move the data from one place to another as you would with any streaming system. It is set up to allow exactly once processing and to scale really easily. Let's take just a moment to look at Stream Analytics, because I think it's probably the one that probably the fewest people in here have seen, I'm going to guess. So Stream Analytics, that's not it. That is Event Hubs. Stream Analytics is a pretty easy interface to use. What you would do is, I've got a job that I think is running. Let's see, did it never start up? Oh, my serverless database wasn't up. I don't know if this is working or not right now, but that's okay. I can still show you how you build it. So the inputs. See, I said I spun up all my clusters. I didn't say I spun up my Stream Analytics job. Inputs is a place for this particular job that I can go and say, this specific event hub, in this case, it is called something like Streaming Demo 1, is out there. I've set up permissions, and I want to read any data that comes into it. That test is probably going to work. We'll ignore it. You can also have reference input. Your options are a little more limited here. You can have reference input to do joins, like in this case, I'm looking up my taxi zone. Same thing I did in Spark to look up a taxi zone name. I'm doing it here. I'm going to need an output. In this case, I'm just outputting back to Event Hubs, which some use cases call for that. There's actually quite a few different output options you can have. And then there is the query is kind of the core of it. This is your logic. And so we're going to select into one of these output items, and we're going to select from our input items. In this case, I have a fairly simple join just on ID, just doing a lookup of a few columns here. And then I'm going to aggregate the data over a window. So when you get to streaming, you'll definitely need to think about windows. How am I going to calculate these data? So I'm not just always doing the totals for all time. I'm going to do just the totals for the last minute worth of data. And you can do a little bit of testing and viewing that here. You can also start a job, which is what I did. That's why so much is grayed out, because the job's actually running right now. And the reason is it's so hard for me to do this live, but when you do Stream Analytics, you can see I stopped producing data. I'm still paying for resources, but I stopped producing data. I got data coming in, data being output, and the output data is less because I'm doing aggregations as you saw in that query. It shows me that resource utilization is pretty low, but something was happening on the job. And I think since I still have it running, it's still charging me. So let's stop that now, save me some money, hopefully, and get back to kind of wrapping this thing up. So that's Stream Analytics, a little faster than I meant to do, but honestly, I've got a longer YouTube video if you want to see a longer version where I kind of take just a little more time to explain this stuff. So, oh, how did I end up back there? Oh, you're with me. Okay, we got it. My screen shows something different than Teams does, so we're here. Data Engineer Certification, that is my first slide there. So things that it's about. Why would I do the certification? Maybe it'll make you more marketable. I hope it does. I don't know. I don't have any polls that say whether or not it helps you get a better job, but it's recognition of your skills and abilities, and it'll get you to learn this stuff, at least to a level that you could walk in and talk about it. And if you're given an assignment to work with it, you jump in and you got some familiarity. It'll make sure you work with this stuff before you you pass this test. At least I believe that's the case. That was my experience. I actually had to get hands-on, test this stuff, monitor it in order to feel confident going into the test. It's going to test. This is kind of the official stuff. data storage implementations, data processing, data security, and monitoring and optimizing that stuff. So if you look at the technologies I've talked about today and you actually run through tutorials, change them a little bit so you see how the code works, monitor them a bit to see if it's working or not. It's really good if you've gotten a little deeper with at least one or two of the technologies so you can answer some of the tougher questions that'll pop up. And if you get to that level, plus you go through some good kind of, here's what this offers, the capabilities of the product become more important in a certification like this than they might be in your day-to-day when you only need a few capabilities that they offer. So the recommendations, these come from Derek Easterly, who presented this with me before and had some really good advice. Budget daily time to study. Do not cram at the last minute. I mean, maybe cram at the last minute, but before that, study every day or on a regular cadence to make sure you're up to speed. Use Azure Learning Pass is the place I would point you for this. If you have trouble finding it, message me on LinkedIn and I'll just post a link for everyone on LinkedIn. And then take practice exams. I did not do this, but I also was fortunate to get pulled in to help kind of coach people through one of the courses for the older version of this. So I got to kind of see see a little more of the practice exam type stuff and the stuff you would need to know. I got to kind of sit in on that just by helping make sure people could get through the labs before. So that was really helpful for me. And most thing to know is that if you put in the time, you can do it. If you don't want to get certified, that's cool too. If you want to be a data engineer and you're going to put in the time to learn some of these skills I talked about and try and make sure you bring some of these mindset to the job that I described, I believe you can do this. I believe you can succeed in data engineering. Getting the first job in data engineering is tricky. It's a whole different topic, unfortunately, and I'm not the best to answer, but I talk about it from time to time. Getting that first job's tough, but you can do it if you put your mind to it and put in the time. So thank you. This, again, is how you would contact me with follow-up questions, find more content, find some longer demos, and you could feel free to request demos if it's about some of the stuff I talked about today. It probably wouldn't take me that long to record something and throw it out there. So if the people want it, I can make it happen. Thank you so much for your time. All right. I think you're muted, John. I guess, are there any questions? I think we have some time for questions. Am I? There we go. All right, Johnny, I don't hear any questions coming in. Do you have anything that's been asked, John? You're still muted. I think I see you talking there.
How about now?
Hey, we got it. Okay. I might have had my sound off for a minute or two. I couldn't tell. So hopefully we're on track now.
Okay, perfect.
All right. I don't see questions. Or did they happen already?
Have any questions?
Oh, here's a few back early on. Let me look at these and see if there's any more.
Can you hear me, Dustin?
Yeah, I can hear you.
Perfect. I think there were a couple questions. For some reason, I think Jan was trying to address it. Let me see if I can read them for you. The system just slowed down from my end. Yeah. By the way, that was an outstanding presentation, Dustin. For some reason, the system is kind of very slow from my end, and I'm not sure what's going on. Just give me a second. I'm scrolling up to see if I can read a couple questions.
Okay, I see. I can address one. Let me see. All right, so Kevin asked a question about replacing jobs, and I see there's a good response on Paul Hunter about Azure SQL jobs as an option. Another option besides SQL Agent or Azure SQL jobs is to use Data Factory Synapse pipelines to trigger jobs. You can call stored procedures. You can do different data flow tasks like I tried to describe briefly. And so I'd say that's an option there. The Databricks jobs is really to run stuff within Databricks, in case that was more where the question came in. I'm trying to think of the timing where was it when he's asked that. So the Databricks jobs are to run Databricks things. And so if you're doing stuff outside of Databricks, I don't think those are really going to help you unless you have Databricks notebooks call out to other things, which sounds more trouble than it's worth a lot of times, in my opinion. Did you want to follow up with anything, Kevin? Let me jump to latest. All right, we'll come back if there's more there. So I don't know. So I would just say, as far as like whether or not I've seen Databricks and Spark used a lot for offloading work that can't be done or isn't easily done on the SQL Server, whether it's Azure SQL or whatever. I do think you can, I mean, I interact with Azure SQL Database as a source or destination for Databricks fairly often, but it's a very different paradigm, right? So if you're trying to write a lot of SQL code and execute it, I expect you could do that with Databricks and Databricks jobs, but you're kind of paying for a lot of resources that aren't doing a lot if SQL Server is doing the hard work, if Azure SQL DB is doing the hard work. So I may have missed exactly what you're after there, but that's kind of my general take on that topic. Paul asked a really good question about ARM templates, and so I'll give a blanket answer, which is not as much of what I think should be done with ARM templates as possible. I think within Databricks, unless something's changed, I will say my production stuff with Databricks, we're using Terraform rather than ARM templates, but there's things that like clusters and things that I'd like to have created via ARM templates that I don't believe you can do yet. But the workspaces and kind of a lot of those capabilities are possible through ARM. It gets tricky. I think the infrastructure as code model for these data tools is probably still getting better, and I hope to see it get better as we go forward. Really good question about IBM DB2 format. I just don't know the answer. Sorry, I can't help on that one. Repos in Databricks. Yes, someone answered that supports Git. Cool. Oh, I didn't show it, but Synapse, the developer portion of Synapse also supports connecting to a repository either in Git or Azure DevOps, DevOps Git. Did you catch anything else we should chat about here?
No, so far you already respond to most of the questions. Yeah. Are there any other questions, guys? Let me give you access to unmute yourself if you want to talk to Dustin as well. So this way you guys have access for that.
So I see one more question is about where to start if you don't have much experience with cloud technology. So I'd say if anyone else has guidance, throw it in there. But I like the Microsoft Learn Pass if you're going to learn Azure. I think they're free and pretty easy to use. Pluralsight has a lot of stuff if you want to subscribe to that for a bit and use their stuff. I like the Microsoft Learn stuff quite a bit. YouTube, conferences, these sessions, really good way to learn as well. Often you'll find some intro sessions, which might be a good way to start. Watch a few YouTube videos that are like introduction to this technology, and then maybe go try and get hands-on with Microsoft Learn.